We all know what a parabola looks like. The one in the diagram has equation y squared equals 8x, or if we write it in parametric terms, x equals 2t squared, y equals 4t. In general, we say that the equation of a parabola is y squared equals 4ax, or x equals at squared 2at. We're now going to look at the significance of that letter A. Let's look a little bit further down and bring this fellow up. And here we have a parabola, and this equation of this parabola is y squared equals 4ax. One or two special things about it. The point down here at A0 is called the focus. So firstly, we can talk about the focus. Is the point S, which is A0. Secondly, this blue line, x equals minus A, is called the directrix. Just have to get used to the words. The directrix is the blue line, x equals minus A. Something a little bit more familiar to you, the vertex of the parabola is the point 0, 0. Now, the rather special property of a parabola is that if we take any point on the parabola at all, the distance from P to the focus, PS, is equal to the distance from P straight to the directrix, in other words, 90 degrees, the distance PM. Now that is a special property of parabolas. So for any point P, PS equals PM. Well, let's prove that. Firstly, let's just look at the distance from P to M. From P to M, well, the x-coordinate of P is at squared, so the distance to the axis is at squared. This is the line x equals minus A, so the distance there is A plus at squared. To find the distance PS, we look at PS squared, which will be the x-coordinate minus the x-coordinate, at squared minus A squared, plus 2at minus 0 squared. At squared minus A squared plus 2at squared. Okay, let's just move the board a little bit, give myself some space. Multiplying out, we get a squared t to the 4 minus 2a squared t squared plus a squared. Squaring the bracket at the end, I get 4a squared t squared. That then is a squared t to the 4. Then we have minus 2a squared t squared plus 4a squared t squared. That gives us plus 2a squared t squared plus a squared. Well, I hope you can recognize that that is a t squared plus a all squared. You should be able to see it because we've just worked out at squared minus a all squared with a minus. So if we've got a plus there, it must be at squared plus a all squared. So if we want PS, we just take the square root. Taking the square root, we get at squared plus a. And if we look, we see that at squared plus a is the same as PM. So we have proved what we set out to prove. We have this new idea now, or two new definitions. We have the idea that if we take the point A0, this is called the focus. There is a good reason for the word focus. Those of you that have had my talk on parabolas and putting bulbs at the center, or light bulbs, or alternatively satellite dishes, that is the focus where all the rays coming in are reflected through. It's the focus of your parabolic mirror. So PS, S is the focus, P to M, M lies on the directrix. So directrix and focus, you have to remember what they are, and they come from the standard equation, y squared equals 4ax, the focus is at a0, and the directrix is at x equals minus a. Okay, let's look now at one or two very simple examples. Firstly, let's find the focus and directrix of the parabola y squared equals 28x. Well, remember that if we have, with the general equation, y squared equals 4ax has focus a0 and directrix x equals minus a. So if we write y squared equals 28x as 4 times 7x, we get that a is 7, and therefore the focus is 7, 0, and the directrix is x equals minus 7. Okay, second very simple example. Find the focus and directrix of the parabola x equals 9t squared, y equals 18t. Well, our general parametric equation is x equals at squared, y equals 2at, and this has focus again at a0 and directrix x equals minus a. So if we look at x equals 9t squared, we've got that a equals 9. Does that work with y? 2at, 2 times 9 is 18, yes. And therefore, the focus is 9, 0, and the directrix is x equals minus 9. I will leave you to read pages 45 to 51 in the textbook FP1.